Hello. That's for everybody. So no class Friday at all.
I don't know.
No, because the holiday of Good Friday.
Yeah.
Yeah, but you know Dr. Jurgens, so that's what I'm saying.
Yeah.
I don't know about other professors. I cannot speak for them. All I can say is that for my class, because the schedule initially said for Good Friday that we were going to be off, that I'm sticking to the original academic calendar thing. But I don't, like I said, I'm not speaking for everyone, so don't go getting me in trouble. If one of your other professors has decided that because we're doing it from home that we need to meet that day or something like that, that's not up to me. That's between you and your other professor. So all I can do is speak for my class personally, but we will not be meeting on Friday because of, yes, Good Friday.
The homework that we have, how are we to ask for help about it?
I'm sorry?
The homework that she posted, how are we supposed to ask for help to get help on them?
That's what the office hours stuff is for. If you want to schedule a specific meeting to get on Zoom or something, then we can, but otherwise post your questions in that Discord thing or talk to me in the Discord thing.
Okay.
So I'm always logged in, but I may not.
And you're frozen.
I may not be actively in the voice channel. So if I'm not, then just send me a message or write a message in there saying, hey, Dr. Neen, can I talk to you? And I'll get a notification for that message. And then I can hop in the voice channel if you want to discuss it. Or we could set up a meeting through Zoom. But those are the ways that that stuff works.
Okay.
Yeah, but also feel free to post a question in there for other students, because maybe one of them figured it out and can tell you. I always support that because it's helpful to them to try and explain it, and it's also usually pretty helpful for you because they are mentally closer to where you're at than I am. So I can't always think about and understand all the difficulties that people have because I'm just not in that headspace anymore. I'm, past it. So I want to be, try to think about what kinds of issues you guys might have, but I don't know. I'm less likely to just because I'm so far removed from it. So that's what the that little message type board thing is kind of made for. Is that you can post a picture and write out a little explanation or ask other people about it, and maybe they can help, or maybe I can help. It's just an extra tool, so I suggest using that. Okay, good questions. So, all right. If you have not done so, please sign in through the chat. Just type your name or here or something like that, so I can get a timestamp with your name on it. Otherwise, we will continue on. All right. So one thing we want to talk about, we've been discussing light and how it moves, how it transmits. Most recently, we started talking about reflection and refraction. And to get an idea of what's actually going on, we need to bring up kind of a little guideline or a rule. And this is called the ray. The ray approximation. So, what is a ray? And I don't mean like your uncle.
Not Uncle Ray.
Yeah, no, not Uncle Ray. He's not in this conversation, unless he's a physicist, in which case.
A ray is directed, I want to say, beam of light or light fragments, I guess you can say.
So, in this case, I mean like mathematically, what is a ray?
Oh God!
But a ray of light. That's the point that we're going to get to, is that light gets treated like a ray when we are doing this thing called geometric optics. But what is a ray mathematically? So you would have gone over it when you talked about, I mean, I can't remember how far back it was. Could have been elementary school, maybe middle school.
A starting point and an end point?
Close. So something that has a starting point and an ending point. So you start and you go to it. What is, with a specific start and an end, what is that called?
A line. Oh, I can't see that. A dagger?
No. So that.
You're talking about like a line?
That's a point, right?
A vector.
Okay. Cody said what I wanted. And I think Dakota said what this is. So what is this?
Line segment.
A line segment. Exactly. So a line segment is not a line. And this is, we're getting into geometric definitions here. A line is infinite.
Yeah, I was going to say a line never stops, technically.
Yeah. Now, a line segment that has a direction is, like you said, it's a vector. But a ray has a starting point and a direction, but there is no end point, really. This is weird. It's almost entirely direction. There is no real magnitude to it, but it starts at some point and it goes in some direction and never stops, theoretically. So it's like half of a line. It's only infinite in one direction. I know we're getting, semantical, but these are geometric definitions. And if you take, I can't remember which of Dr. Lane's classes is, it's not geometry, but it's like proofs. So if you end up having to take that class for your math and computer
You
science,
talking about discrete?
maybe. Like I said, I can't remember. There's one that he does a ton of geometry because that's one of his things, and geometry has a lot of proofs in it. So these things kind of come up, but array is an arrow that we don't really care about its magnitude. So you could maybe think about it that way. It's a vector that it's not that its magnitude is 0 or in it, like it just doesn't matter. It's pure direction. And so we often say that it has infinite just because it's always going that direction. So we'll say in quotes, that pen is just about dead. So it's a pure and so the reason we say this, that it has, infinite or never-ending magnitude or length, is that if a light ray were to just start going, it would never stop unless you stopped it, in which case you have to, talk about what it took to stop it. But once a light ray goes, unless you get in its way, it will just keep going. And so the book says this as light travels in a straight line path through a medium until it encounters a boundary between two different materials. And that boundary, as we discussed last time, one of two things, or sometimes both, but two things can happen. Either the light will reflect, so it bounces, or it will refract, meaning it goes through and bends. Okay? So one of the pictures they give for this thing is so a plane wave of light traveling to the right. So the rays, all the blue lines, give you the direction that the light is going. And this is where it kind of gets weird. Light is a wave, just like a physical wave traveling. So what happens if we drop a pebble into a pond? So let's say maybe it's not a pond, maybe it's just a big pool or something. What happens when we drop a pebble
Thanks.
right here? What?
Not radio waves, ripples.
Or ripples. Or you
Ripples,
tossing it like.
But you were gonna say, you said the shape of it. It's another R word. I think it was Aaliyah.
Radius, I don't know.
Rings? Did I hear that?
Yeah.
Okay, so it creates ripples in the shape of rings. But there's one leading ripple.
Yes.
So after, I don't know, a couple seconds, it might look like this. And again, my penmanship isn't great. So what you're actually seeing, if you were able to like cut in half, what you're actually seeing is flat water, and then 1 ripple, 2 ripples, 3 ripples. So what you're seeing as the line is usually a peak. So the wave is traveling outward from the middle. So this is one of the weird things about waves is you have to actually think about a bunch of dimensions all at the same time. So the wave front is this ripple, okay? So it's like this part is the wave front. But the direction of the wave, so in this little image, the direction of the wave, they use the fancy word of the direction of propagation of motion, just means which way is the wave moving. In this case, what direction is the wave moving? So
Outward.
okay, great. Yeah, so it's moving outward. So the rays of this wave look like this. All right, and I mean, you know, you can put more in there somewhere. The point is that the wave itself kind of, if you're talking about the wave front, like if you're at the beach and you see the wave, the wall coming at you, that's the wave front. The direction, though, when we start talking about the rays, is at you. And usually the wave front is perpendicular to the direction of propagation. So the ray is pointed perpendicular to the front. So there's the front, and it's moving perpendicular to it. Okay, so we're going to put away the wave front thing and just kind of treat this as its rays, okay? Which is a little weird, but we're just talking about the direction of the light. So, reflection. When you have light that is going along and then it comes into contact with a boundary, it will do one of two things. It'll reflect or refract. So the first thing we're going to look at is reflection. There's two different kinds. One is called specular and diffuse. So can anybody maybe give me some kind of meaning for one of these two things? Preferably from something else. What does it mean?
Well, to diffuse, I know means to break apart or to like separate.
Yeah, to separate or scatter is another good one.
What's the other word?
Specular. What do
Kind of like a mirror.
It's a mirror does specular reflection.
Is it a reflection? It would
These are
Like a
both kinds
mirror?
of reflection. So it's probably the opposite of this. But if you have specs,
Does it have to do with a horizontal and a vertical line?
not quite. So
Surf.
I guess I don't know what you mean by a horizontal and a vertical line. So it's just the opposite of diffuse, is it doesn't separate. It doesn't scatter the light.
So that one doesn't spread and the other one spreads, basically is what you're saying.
Yeah. So we'll just say that it keeps it together or focused. So that's what your specs do, is they kind of help bring the light together. So the book has a nice little picture of this. So if I can get my computer to cooperate. So this is a wave front coming in. Okay, so it's one wave. And when it comes in and it bounces, and then as it goes away, it's still together. All of these things are still lined up. They're in kind of the opposite order. So this one was on top and this one was on bottom, but then when they go away, this one is on top and this one's on bottom. So they flipped, but they're still the same distance away from each other. They're still all going in a nice, neat little line. So this is specular reflection. With diffuse reflection, it happens when you hit off of a rough surface. So I think Dakota maybe said when you hit a smooth surface like a mirror, it keeps everything together. But if you come into with a either a really rough mirror or a intentionally funnily curved mirror, this can happen. Light bounces off all over the place. And in this one, there's a laser that comes in, boop, and then it leaves and a laser goes out. So it all stays nice and neat together. But on this one, the laser comes in and it hits and nothing comes out in a nice neat line. But you can see it's a lot more lit up all around here than it was in this picture. That's because the light comes in, it hits, and it just scatters. It just goes everywhere. And this is the difference, I guess, between a specular and a diffuse. Most of the reflection that you see, that you actually don't generally think of diffuse reflection as reflection, but it happens probably more often than the other one does. So in diffuse reflection, this is like when light hits an object, like a leaf or a rock. The light goes everywhere, and you can see that rock from every direction because the light is bouncing off in all directions. But if light hit a rock and was specular, you would not be able to see that rock unless you were perfectly on the other side. So if the light source is right here, you would have to be standing, your eyes would have to be right here to see that rock. But when you have diffuse reflection, it goes all over the place. And that's generally what happens in your everyday life. But it's not usually what you think about as reflection, because you think of reflection as a mirror or as specular. Which is, fine. But that's the main difference. Okay, so we're going to talk more about this specular reflection. And we're going to look at a single ray for a second. So here is our mirror. Actually, let's draw it. So the light ray is going to come in, and it's going to reflect. So this might have been what you were talking about the two perpendicular lines. So this is called the incident ray, the one coming in. And this is the reflected ray. So experimentally, we proved something about how these things reflect. So let's draw a perpendicular line. And who can remind me what the name of a line that is perpendicular to a surface is called? What do you call a line that pokes directly out of a surface?
Parallel?
No. It's the
Hook and tooth.
it's the direction that that surface is facing is the way we called it.
What did it start with?
Starts with an N.
Normal?
The normal. Yeah. So this line is called black. This line is called the normal. So the angle of incidence, or of the incident ray, is theta. And the angle of reflection we'll call phi. Relative to this normal are actually the same. And this is something that most people are pretty on board with fundamentally, is whenever you see something come in and bounce off, you know that it kind of bounces off symmetrically, right? It's pretty, if you've ever played any sport that required you to, hit a ball off of something else, this is what we see, that the angle of incidence equals the angle reflected.
So that's just like me passing a ball to somebody.
So if you're kicking it off like a wall, I mean, technically everything bounces like this pretty much, unless it has a ridiculous amount of spin on it. but we're ignoring that case. But like this is like, I don't know if you've ever played pool. You need to hit a bank shot. The ball comes in at some angle, and it's going to leave at the same angle relative to that normal line. So when it bounces, it's going to bounce off that way. So this is like, you could never have a line that comes in like this and then bounces that way, right? It's not going to happen. If a ball comes in steep, it's going to leave steep. Or if it comes in shallow, it's going to leave shallow. This is the idea that the angle coming in is the same as the angle going out. So let's see. How do we want to discuss this? There's a couple different examples. So this is a pretty good one. Has anyone ever been standing at a window, usually of a very big office building, and been looking at their reflection? Usually has to be a very sunny day, and you can see your own reflection, but it also looks like a copy of your reflection, like really almost inside of your other one. Like it's a very weird.
Like when you stand in the mirror and take a picture, and it's like behind. Like if you angle the camera a certain way, it shows like you multiple times.
No. I'm trying to think. Kind of, but it's not. Not exactly. You could say it's. Looking for a picture, but all this is showing me is double windows. So the behind thing, you could say is kind of linked to this, but that's a little bit more drastic. Thick window. I just cannot see a good example of this, which is driving me crazy because I had seen it before. Not going to be able to find it, I can already tell. So we'll just ignore that example. What's another one? Crap. It's gonna drive me crazy. Okay, so I'll just not worry about that. So what it looks like is if you have person, and this is you, what it looks like is at the edge, there's actually another U that's a little bit smaller. and it kind of makes you look blurry. But it looks like there's a U, and then there's a U stuck right on top that's a little bit smaller. And this happens if it's got to be sunny and a really thick window because of how reflection works. Reflection and refraction happen whenever light tries to change mediums. So it tries to go from going through one thing to another one. Usually it's air to glass or air to water. These are the most common ones. But if you have a very thick window, then you have the front of the window and you have the back of the window. So when a light ray comes in, some of that light bounces off, but some of it keeps going in and then bounces back. So when it comes to your eyes, you have the normal main reflection, and then you also have a kind of a dimmer one that's stuck on top because they both come off and they add together. But it's entirely at the transition between, or at the edge between two materials that reflection happens. So if you have a really thick mirror, a thick piece of glass, the first reflection happens at the outside, but then some of that light goes into the piece of glass and it reflects off of the other edge of that mirror. So you have air, glass, and then the inside of the building, again, air. So what you're talking about is another thing that can happen is if you have internal reflection that tries to keep light inside something, what you get is, if you have a mirror over here, and one over here, if you are, let's say right here, looking this way, light came from somewhere and bounced off this mirror and hit you. But some of that light came from over here. So it came over there, bounced in, and hit you. But some of that light came from over here. So most of the light that you see is from the main image, or the biggest looking mirror. But you have a smaller mirror because the light went this far and then came back before it bounced off and got to you. So the first mirror within the mirror is because the light bounced and came back. The second mirror is because it did it again. Boop, boop. And you get an infinite number of mirrors because the light can keep bouncing over and over and over. But they look smaller and smaller because the light had to travel further to eventually get to you. We're about to run out of time, but yeah, so that is pure internal reflection, which we will talk about next week. So y'all have a fabulous rest of your evening and a great week.